Welcome to the lesson Writing Secure HTML. After watching this video, you will learn secure HTML practices such as how to avoid cross-site scripting attacks, how to encrypt your HTML data, and how to implement CSRF tokens. One of the most common cyber attacks conducted through HTML is cross-site scripting. Cross-site scripting is a type of cyber attack where a hacker enters malicious JavaScript into a web page. There are three main types of cross-site scripting. Stored cross-site scripting, where the malicious code stays in an application as it gets saved into a database. Reflected cross-site scripting, where a URL can run a malicious script. And DOM-based cross-site scripting, where the script is stored in the DOM. Modern web frameworks such as React, Angular, and Vue handle cross-site scripting protection through built-in input sanitization, and many browsers today can detect cross-site scripting and prevent malicious JavaScript from running. However, there are still cross-site scripting attacks available, and it's important to learn how to avoid them. One of the most important practices to avoid cross-site scripting is to not use inner HTML when accessing the content of an HTML element. When setting HTML elements using inner HTML, a hacker can enter JavaScript that can be executed. Instead, use text content to get the text data from an HTML element. When you use text content, it handles the data as plain text and not HTML data, so it can avoid you from running cross-site scripting attacks. Another critical security practice is using cryptographic hashes in your HTML elements. By adding an integrity attribute with a hashing algorithm to your elements, you can ensure their integrity. Here's an example of a script tag in HTML that uses the integrity attribute. When the browser loads this script, it compares the provided hash with the actual file's hash. If they match, the script is executed. Otherwise, it's blocked, preventing potential man-in-the-middle attacks. The final secure HTML practice you will learn in this lesson is CSRF tokens, a defense mechanism against cross-site request forgery. Cross-site request forgery is a type of security attack that tricks a user into unintentionally executing malicious actions on a web application from a different page. Here's an example of a cross-site request forgery attack. A user is logged into a bank website that has a form to transfer money. While you're logged into the bank account, a hacker sends a link to a website that has that bank form. Since the user is logged into the bank account and the form has no CSRF tokens, the hacker can alter the HTTP requests that come from the form, thus changing the submitted form request to send money to the hacker from the user's account. This type of attack can be mitigated using a CSRF token. Here's how to implement a CSRF token in an HTML form with a Node.js server. First, we will install packages Express, Express Session, CSURF, and EJS to our Node.js server. These packages will allow us to create a Node.js server with Express Session Management, generate a CSRF token, and send it to our HTML page through EJS. Next, we will create a server.js file. In the file, we will create an Express app and configure it to parse the form data to check the CSRF token and set EJS as the main template engine for rendering views. The file also creates an Express session and CSRF middleware, making the user session secure. Then, in this section, the server sends the client a 403 page whenever there's an error for mismatching CSRF tokens. In the last section, the server creates a default route where the form page lies and a route for when the form is completed. Then we will create the HTML page. This will be in an index.ejs file in the views directory to make it easier for the server to send the CSRF token to the front end. Although it's in an EJS file, the format looks the same as a normal HTML file. In this example, we have the CSRF token stored as a value in the input element. Now when the web server is live, you can see the CSRF token on the page. Since this token is session-based, the form is still secure even if it's visible on the client side. To test that the CSRF token works, we'll change the contents of the CSRF token. If we submit a form now, we get a 403 error preventing us from submitting the form unless the token matches with the server. In this video, you learn to use text content instead of inner HTML to avoid cross-site scripting attacks, to use cryptographic hashes and HTML elements to validate elements, and to implement CSRF tokens to avoid cross-site request forgery attacks.